Let's go. All right, we're live. Hello, everyone. Welcome to the Gala webinar series. We're going to start in less than a minute. Please just take your virtual seat, get comfortable. All right, we're going to start. So as I said, welcome to the Gala webinar series. My name is Isabella Massardo, and I'm the content strategist here at Gala. Today we have a panel of experts who will be presenting the NTEU project, the Neural Translation for the European Union project, and which is organized and hosted by Manuel Herranz, founder and CEO of Pangeanic. Before we get to the presentation and the discussion, as always, we will try to get to as many questions as we have time for at the end of the presentation. So if you have any questions, please type them in the QA box. You can use the chat button on your control panel to chat with other attendees, and you can direct the chat to the panelists or to everybody. This webinar will be recorded. You will receive a follow-up email with a link to the recording, and we'll also post the recording on the Gala website either tomorrow or on Monday at the latest. So Manuel, the floor is yours. You need to unmute yourself.
Okay, so hello everyone. Good morning to those that are on US Pacific time. Good afternoon to our European attendees, and well, good day to the rest of the world. I think it's probably nighttime in Asia. My name is Manuel Herranz. I'm CEO founder of Pangeanic, a language firm with a very strong technology arm producing LB solutions. We lead neural translation for EU NTEU projects, which is about to finish this summer, delivering high quality neural engines and data to ELRC-Share. And I'm very happy and proud to be chaperoned today by my colleagues in this project, Maite, representing a government agency, SEAD, for digitalization and digital advancement in Spain. The agency is fully dependent on the Ministry of Economy. And Artus Vasileskis from Tilde, a colleague, well, a friend really, that has been involved in the project, and certainly somebody whose opinion counts very well, and is a very well-known person in the machine translation world. So, well, and Antonio Dowd from KantanMT, unfortunately, I believe he's sick, and he sends his apologies, so he cannot attend today. So what does NTEU stand for? The project began as an idea in 2017, 2018, early 2018, and it was approved that year as the largest ever neural machine translation engine farm to produce all-into-all neural engines for all European language combinations. So that means that not only popular and large languages such as French, German, Spanish, Italian would be covered, but we would also tackle in something that hadn't been done before. We would farm data, gather all that data, and create neural engines with a fair amount of bilingual parallel data into all languages. So we've created combinations, direct combinations from Slovenian into Greek, Polish into Portuguese, Danish into Slovakian, Estonian into Spanish, Latvian into Finnish, for example. And I want to stress that this is something that is state of the art and hadn't been done before. Typically, large online engines pivot through English. So the idea, which was approved by the European Commission, was to go one step further and gain quality by using completely parallel data that the Commission produces and also that we have farmed in a one-to-one relationship between the language pairs. And then these engines could be used by public administrations in Europe, or as the project has advanced, by the larger language community. So the project was very ambitious from the start. I can't hide that it has created a lot of work at the three companies here. We gathered 3 companies from Europe, leading machine translation companies, Tilde, KantanMT and Pangeanic. And we have produced 506 language pairs, which just about the 506, the project will be completed and fully delivered in August 2021, this year. And we have spent a lot of time gathering massive amounts of data, all in a large grid. So we have 15 million alignments between, let's say, older or popular or large languages, Dutch, Spanish, French, German, Italian, etc., Portuguese. And we gathered 12 million for the lower resource languages, which makes this project a very valuable project in itself because of the data that it holds. So we gathered 12 million for Maltese, we gathered 12 million for the Slovenian, for Latvian, and etc. All these engines, by the way, will be delivered, or they are in the process to be delivered to the European language grid. And the data will be available to the wide machine translation or NLP community and downloadable from ELRC-Share. So we had that objective. The second objective, was data collection, and this in fact was a challenge. There are massive repositories nowadays in 2021, and it is true that things move very quickly in our space. 3 years ago, 4 years ago, when we thought about this project, it was not so. You still had to web crawl a lot and do all sort of things to gather data clean. You had to put humans to review some sentences in order to make them clean. We have learned, I don't hide that, we have learned a lot from this project and from what we can do as an organization to obtain more and more data. So a fair amount of the data comes from DigitEU repositories, with a difference. DGT material is freely available from EU repositories. We have cleaned it. We have got rid of a lot of it for training purposes. So much that it's only about 1/3 or just over 1/3 of the training material that we have used. In fact, there are 3 tiers of quality in the training. That part would be what we call 100% human. And Tilde and Pangeanic have also contributed to that deliverable from their own resources with human quality material. We have proceeded to align data from the web. We haven't really used public repositories, Opus MT or Paracrol for this exercise, and we created a large amount of synthetic data. Pangeanic was in charge of that task. That approach not only helped us deliver what we promised to deliver, to not just talk the talk, but walk the walk, as we like to say, but to create neural engines that are really state of the art. Even though nowadays we are all training engines with far more segments than 15 million, this amount seems to be pretty good at producing results and beating online engines in domain. So the partners also sat down and agreed on a common procedure. We prioritize human material over the synthetic in training ways that are better explained in an academic paper, which will be published later on this year, I think in AMTA or the European Association for Machine Translation. And well, after gathering all the data, we proceeded to training, which obviously was a challenge in itself. Training that large amount of data with a high number of steps and quite a few epochs going around, it takes time, takes software, hardware and software time. So what did we do in order to ensure the quality of the engines? The engines have been approved by humans that are conversant in all language combinations. Initially, the project was going to contract this out to universities, but it was we thought that it better be run independently and in a neutral way by SEAD, by the Spanish ministry agency, since obviously it has no vested interest in stamping the quality of the engines. And in fact, it does have an interest in them running well because they are likely to be used by other public administrations or benchmarked by organizations here in Europe or elsewhere. So we changed the focus from the universities to SEAD. We contracted linguists, and we set out massive tasks to evaluate all 506 engines twice by not one but two human linguists in a benchmark versus free online tools that we all can think about. The point of benchmarking was to ensure that we were not only looking at Blair scores or general concepts of fluency, but we were running a race one-to-one against what people are used to use on a free basis. So this task is almost completed. Many language pairs have fully passed the test, and they are available. Some engines need to be reworked, very small amount of engines in very challenging language pairs. But as Maite will tell later, they're very few, and we expect to complete the project in time. So one question that may come to mind to all of you is about availability. Okay, this is wonderful. You've gathered a lot of data. Thank you, Manuel. Thank you, Arthurs. Thank you, Maite. You've created a lot of engines. That's great. Can we integrate them in our systems? Can I use them as a public administration, as an enterprise company, or as a corporation, as an SME or larger corporation? Well, in fact, you can. Initially, the project was thought to create engines fully customized for public administrations, but the scope has widened. So the engines are going to be available through the European language grid. The challenge here is the uploading, because the sheer size of it is going to take weeks to upload every bunch of languages, and it's something that we expect to complete by the summer. Really, it's going to take about 2 months to upload the whole lot. But yes, the engines will be available as a service and for download from the European language grid. They're fully Dockerized, so that means that they can run practically anywhere. You could even run them on a PC or a very small server. They are ideal for SMEs or small organizations, and obviously, because since they're Dockerized, it's needless to say that the API ready. The API is what comes with Docker, so they're very simple plugin MT engines. However, if you need full customization or you have very specific needs, the consortium has a viability plan for the engines, and we can work together with you to customize more engines. Let's remember that these engines have been customized for public administration needs. So they cover a lot of things. They cover from fisheries to law to social issues, industry, financial, economics, but from a government perspective, okay? So what are the key takeaways of this project? Well, the main value of the project, if you don't want the engines, is obviously the data that has been uploaded to ELRC-Share and is fully available for the language community already, or most of it. Maite and Artus will confirm that, but I believe that Tilde has already uploaded a lot of it to ELRC-Share. The license is through ELRC, so if you want to use it for academic purposes, that's fine. If you plan to use it for commercial purposes, you have to consult with the consortium, and you have to let us know that you plan to do so, because the consortium obviously has to run a live afterwards. Another very cool, really, software product of this project is NTET, the evaluation tool, which again will be fully available to the community as an open source tool, and is a tool that serves the purpose of benchmarking several translation engines or ranking one translation engine, accuracy, fluency, etc. This is a view of one evaluation from Slovenian into Finnish, as you can see, and the tool can be customized, and different ranks, different ratios can be applied to the resulting translations. So this is ideal for developers, for users, or for NLP community that want to use an open source tool in order to rank with humans what they are doing, how well they are doing. It can take a reference from an online engine, from another engine, or from none, and then we just rank how accurate our work is. Okay. In fact, this has become standard at Pangeanic nowadays. So just a reminder, these are the two organizations that are beginning to host the product of this project, which was at the time a very large investment, altogether around 2 million euros to produce 500 engines, which I want to stress was very good value for money. And I hope that you can make use of them and obviously expand your knowledge and make good use of the data. So I would like to leave it here and then pass the floor on to Maite from the Barcelona Supercomputing Center, who will be describing how we've run the evaluation, the efforts, the challenges, and how long it has taken, the people involved, and how good and bad we've done in some language pairs. Maite?
So I hope that you can see my screen. Hello, everybody. Thank you, Manuel, for introducing me. So I'm going to present a little bit what we have done to evaluate this large amount of engines in this challenging project. In fact, the figure of 506 is not correct, Manuel, because at the last moment, English was also introduced in the picture. So we had this this figure at the beginning because we only plan to develop engines for all non-English language pairs.
True, you're right.
Right, yeah. Because those are the ones that no one else
yes,
were
I forgot
developing.
about English. Yes, sorry, mate. Yes, yeah.
We were asked to include English as well, you remember? So
Yes, yes.
yeah. So and then so English was introduced at the last moment. So that's why this matrix doesn't include English, because it was done before at the beginning as in a previous presentation at the beginning of the project. So there's really 532 engines. I'm saying the number okay, right? Because sorry, it's 552 engines. I had this the screen covered, and so the engines were distributed among the three developing companies involved in the project according to target languages. So the distribution that you are seeing here refers to which language was the target, right? So to evaluate the engines, it was decided that we will use real documents from the European Commission. We looked from documents in the DGT that were translated to all 24 official European languages. And we decided to take whole documents, so not randomly extract sentences, but take whole documents for the evaluation. With that, we built a test set consisting of 2,000 sentences with the human translation that acted as the reference. And we isolated this test set from the training data and the fine-tuning data. And we were very strict on that. And with that test set, the automatic evaluation of every engine was performed. And the metrics that have been computed are bleu, TER, F-measure, and perplexity. So here is an example of all the engines trained with Irish as target. And you can see that all these metrics are computed for each of the engines. So this is performed automatically when the engine has been trained. And then comes human evaluation, of course, because as Manuel said, it's not enough to have these automatic metrics to really have an idea of how good the engine is, how well it can perform. So we discussed about how would we do this human evaluation. And in face of the difficulty of finding bilingual evaluators, and this is a reality. I mean, I'm sure that many language pairs don't even have a person that speaks both. Maybe, yeah, but it's difficult to think of someone with competence in, say, Irish and Maltese, for example. So in any case, we decided to use native speakers of the target language. So we designed the whole evaluation exercise with this in mind, that we were going to use native speakers of the target language that didn't have to know the source language. As Manuel has anticipated, we wanted to use a free online tool as a benchmark. Of course, we decided that Google was a good candidate. And we have used this evaluation platform that has been built purposely in the course of the project, and that is one of the big assets and deliverables of this project, and will be open to the community at the end of the project, and it's called MTET. So in the evaluation platform, the evaluator is presented with the reference translation in the target language. So the source sentence, it's not the main source of the information that the evaluator gets, but the reference translation. And then two machine translations, machine translated sentences in random order, one corresponding to the NTEU engine being evaluated and the other one coming from Google, and both, of course, unidentified. And then the evaluator is asked to assess each of the automatic translations, not just rank them, not just say which one do you prefer, but just put a number, and it's a number in a range, in a big range of 0 to 100, and we use a slider for that. So the number of sentences that have been evaluated by humans is 500, and this is a subset of the validation set that I mentioned before, used for the automatic metrics. And then to mitigate human bias, each sentence has been evaluated by 2 evaluators. You have already seen a screenshot of the platform, so that's what the evaluator sees. We are translating into Gaelic, into Greek, from Irish Gaelic into Greek, and so that's what the evaluator sees. And then the 2 automatic translations and the slider and the slide under each of them. Here's another one, and that's the administrator's view. The administrator is able to see all the source, the reference, translation, etc. And then once he has made sure that everything is okay, that there's actual translations coming from the engines, etc. Then the administrator can assign the evaluation tasks to the different evaluators. And from this screen, the administrator is able to manage the progress of the different evaluations. So those are a few screens that show the functionalities of this platform that, as Manuel said, is going to be delivered freely to the community, and has different ways of configuration that so that the other functionalities can be also included that we have not used in the NTEU project. So the evaluation platform and the methodology so far, and the question is, how well have the NTEU engines fared then? So according to our human evaluators, the NTEU engines are far better than Google, particularly in uncommon language combinations where Google probably uses pivots. And here we have a couple of series of examples. The first table are engines that translate into Romanian. And you can see that most of the scores that correspond to the NTEU engines are significantly better than the scores for Google engines. The second table is similar. Here the target is Hungarian. And again, we see that the difference between the column and at the left and the column in the right is quite significant. But it's also better in combinations that are more common. So we see here, for example, that the NTEU engine for Danish-German gets a much better score from the humans than the Google engine. And the same with the English-German. And Portuguese-Spanish, the NTEU engine is really good. It's true that mostly for engines that involve English, we find that the differences are less significant, and that, of course, that makes sense. So, for example, the Spanish English, Maltese English, Irish English, or English Bulgarian. But we have some remarkable exceptions, like here, the English Finnish, for example, English Portuguese. So those results are preliminary results because not all evaluations have been performed, but many of them. We still need to do a detailed analysis of the results, but we can already say that around 80% of the engines are better than Google with statistical relevance. And the other 20%, we can say that they are either similar or not significantly worse than Google. And those are the results that we can happily report for the engines developed in the project. So that was all I had to show you today. And I'm going to give the floor to Artur.
Thank you, Maite, for a detailed overview on the results and quality achievements, actually. And then thank you, Manuel, for a warm introduction. So yeah, before probably we will jump to the last part where we have an option to answer to the questions. I will give you a couple of insights, actually, how challenging this project was. And particularly the data. The data, of course, is the basis or the essence of this project in order to have such huge amount of the engines. And to give you some examples, so we managed to collect more than 6 billion of parallel sentences. And if you transfer this amount into words, it is more than 1.3 trillion of words. So it's a significant amount of the parallel data, and the consortium was facing these challenges where and how to accumulate such amount of the data and distribute between the partners to launch the trainings. So concerning to the data status for now, so we are now finalizing IPR related matters, and the goal is to have the data available for the scientific use, scientific experiments at the ELRC-Share platform in next couple of weeks. So the data will be available. So if you have any questions, so please also do not hesitate to contact consortium. So we will be happy to provide any suggestions, clarifications in terms of the data sources of data related segments from which data was gathered. So additionally, we have challenges which we addressed with the additional crawling of the data is data related to languages which are highly inflections. So in order to have high quality engines like just might presented for the languages like Latvian, Finnish, Hungarian, we applied a specific filtering methods. So in order to reach a high quality results in terms of the quality. So those was a couple of main challenges which consortium addressed, and yeah, actually we will be happy to share our experience in remaining time. So if you have any questions, I then would give a floor.
In the meantime, while attendees are typing their questions, how about we launch the poll for everybody, right? Okay, here we go. So this is the poll for the attendees. I'm going to read the question because those who will be watching the recording won't be able to see the results. So the question is, what would you be willing to incorporate stock MT general engines in your processes? Let's give it a minute. Okay. Few more seconds. Okay, I'm going to close the poll, and here are the results. The yes is 62%, maybe 31%, and the no is 8%. Thank you all. So yes, I see a couple of questions. First of all, a comment from Pete Smith. He calls your project a visionary project and a wonderful cooperation on a true international scale. That's nice. There was a question from Renat Bikmatov. Let's see. He asks, how did you isolate the test data set from the training data set? And I believe that was for Maite. I don't know if you want to take this question, Maite or Manuel.
Well, I wanted also to make sure that that was true, but I think it's for the developers to explain how they did it. So
yes.
I was very strict in this.
Yes, we followed standard academic practice. So the evaluation sets were separated very initially at the beginning. Most of it coming from public administration's material because it was available from DGT repositories. But then we added some more as we gathered more material. We added some more from other sources. I have to say that public administration material from DGT, even though it's public administration, is very wide, really, because there are so many laws, instances of people standing up and speaking on behalf of the nature fund of sparrows in the Nordic region. Then that person stands up and talks about not only the sparrows, but also all the birds that the sparrow meets migrating from Africa, and what the weather conditions are while it's flying and not flying, and what other companions, bird companions, meets on the way down and up from Africa. So it's very good material, really, for covering a very large and a very wide spectrum of language. However, it's not enough for very specific areas. It's not enough for, let's say, mechanical engineering or deep astronomy, etc. So those or for conversational language. So those areas had to be supplemented to a degree. Or news, for example, it doesn't translate very well news. So those areas had to be supplemented from other sources, from Wikipedia. We created ways of gathering material from synthetic sources, from chatbots, from web crawling, etc.
As for no, but the question was, we made sure that the test set was not in the
completely.
And that was Tilde that I think that took care of that, because they took all the data coming from the DGT and ran a script that made sure that the data was not there. So the results are fair in that sense.
Yeah. Otherwise, it would be cheating ourselves, and
right.
in any case, we're dealing with 15. Some engines are over 15 have been trained on 17, 18 million segments. So, subtracting 2 million, 2,000 or 3,000 sentences has no impact on the training, and it does give you a very good measure of what you are doing, which is what we wanted to do.
Okay, there's another question, again from Renat. Did you align the monolingual data, and if so, which tools did you use?
Sorry?
Did you align the monolingual data, and if so, which tools did you use?
We use web crawlers for aligning websites, but web alignments can give you surprises, let's say, because some people put out machine translated content and they don't warn you about it. Or some people transcreate rather than translate. So data is not truly parallel. An example of this is Paracrawl, a very large data set that we are familiar with, and which contains something like 17% noise. Now, with such a large amount of noise, well, it is going to really grab any training, because neural networks are extremely sensitive to any type of noise. One sentence may pass through, but if 2 or 3 sentences start playing up, then the whole engine is going to give you funny results. So we used aligners, btext, obviously, aligners, very similar to what Paracrawl uses, but with really extreme, very strict cleaning procedures. So that material was very, it was only, I'm not going to say small proportion, because in 15 million segments, everything is large, but it was not the largest set in the training.
Okay, yeah. I think actually you already replied to 2 or 3 questions in one shot, because there was another question from Atsuko Teshima who asked, for example, what are the best techniques to remove dirty data from the engines?
Okay, you're asking a baker to give you the secrets. What a nice bread! I haven't smelled bread like this in a long time. It doesn't smell like the bread I buy in Walmart or in Carrefour. Well, there's some basic features like sentence length that are pretty standard. Punctuation can give you a clue as to what something is, what is happening, but it's not definite. For example, if a source sentence ends with a full stop and the target doesn't, well, there may be something, not necessarily, but there may be something in there. So that was, for example, one of the cleaning basic cleaning routines that we had. Sentence length is another one. If you have a sentence that is 20-30% longer or shorter than the other one, something's happening there. Then again, it may be completely okay, but only a native speaker will tell. And now, pulling 500 native speakers to comment on if a sentence is good or bad, it wasn't viable. So you have to approach things in a very, with big data kind of mentality. And even though you might get rid of sentences that are perfectly okay, chances are that in the process you've really cleaned a lot of noise. So those two are the main ones, but they're very basic. Other thing, for deep cleaning, really you need to use things like bank of words, add a little bit of syntactic or semantic knowledge to the cleaning tool. So you already know what some words are happening in the target language. You pull out something that is not strange. That also creates a kind of style in the engine, because you eliminate the chance of some vocabulary then again, which may be okay, but it's not standard in your bag of words.
Okay, thank you. All right, let's see whether there are other questions. I think we're replied. Okay, another one from Almudena. In your opinion, how is the average quality of other available corpora on the internet? She comments, I know that Paracrawl and DGT, but other reliable sources like Opus or other corpora, sorry.
Well, I think Artus can comment on Paracrawl, because I know Tilde has done very extensive experiments on Paracrawl, and they're not very satisfied with it, because it contains it's a very good effort, but you have to clean it, and you can do that. I mean, anybody interested in big data can pull one of the language pairs that he or she knows, pull out, let's say, 100 or 200,000 segments and filter them in alphabetical order, and you will immediately realize that there is something odd here and there, and that is the 17% that I'm talking about. That unfortunately, even though 83% could be very, very good, unless you're extremely careful in your cleaning procedure, you're going to add some noise, and that's going to have a detrimental effect on engine training. Then again, DGT2, but it suffers, particularly the first versions. The older the TM, the more noise it has. I have cleaned it a lot in the last. Let's say, 2 years, since 2019 or so. It's more standard and cleaner. But the older TMs coming from 5 year 6, they can be noisy. They can be noisy. Opus is a collection of all those that I've described. It contains part of Paracrawl, DGT as well. It's very good, but it also contains open subtitles, which is very noisy, because of the freedom and the liberty that subtitlers use in the good doing of the daily work. You know, some expressions, from swearing words to local expressions, cannot be translated literally. You have to translate with an expression, which bears no resemblance. You know, like, let's not cry over the what is it? The milk that we dropped.
I think was the spilt milk, but
spilled milk. Okay, yeah, spilled milk.
I think we have English native speakers. Maybe they can confirm.
Yeah, that's it.
We got it right.
All right, so I know 1 or 2 languages where that would work. Spanish definitely, but maybe in other languages we're not even talking about milk. You know, we're talking about the car that has left, or the train that has left, or the meat that we're going to eat. So subtitles are definitely not a good idea, and in fact it's an area of research for most of us, you know, how to very well translate subtitles. Okay,
Artus, would you like to add something?
Yeah, spill milk. Yeah, I can see it. Thanks, Pete.
Actually, to add to what just explained Manuel, on top of the filtering, what was I believe how we come up with the solution. We splitted corpora in several so to say divisions for the corpus quality. So we split it like high quality data produced by the humans, translation memories, for which we applied a higher weight during the translation, and the low quality data for which we applied heavy filtering, and those data was used with the lower weight proportion during the training. So and actually that gave us a quality jump, and much less error rate during the translation. Yeah.
Okay, and Pete is commenting, What an excellent example, the spilt milk from Manuel, probably. Widely used phrase with translation challenges, but linguistically spilt sounds quite archaic to me.
Spilled
Okay.
milk, yeah, spilled milk.
Thank you, Pete. I think we don't have any other questions. So we've reached almost the end of the webinar. Thank you so much, Manuel, Artus, and Maite. It's been really interesting. Thank you to all attendees. Next week at Gala, we have something completely different from training corpora, MT, neural, whatever. We have a panel on the future of the localization industry. Panel discussion with 6 young localizers, and it will be moderated by Beluga, and I hope that all of you will join us. And in the meantime, I wish you all a good day or a good night, depending on where you are. And thank you again, Manuel and Artus and Maite. It's been a pleasure having you.
My pleasure.
Bye, everyone.
It's been a
Bye,
pleasure.
everyone.
Thank you.
Bye.
Bye-bye.
Bye-bye.
Take care.
Bye.
Bye-bye.
Bye.